mesh kinds of calculation. Okay, so let me give you the last process and the more interesting process and useful process also, that is the Lagrange multiplier. So what we have to do here? So let me do the process C for this problem, and that is Lagrange multiplier. Okay, so what we have two functions actually. One is f and another is phi. So let me convert this y is equal to 1 minus x square as phi. So you have y is equal to 1 minus x square. So we have x square, y plus x square is equal to 1. That means if you take it as phi, that is obviously x comma y is equal to constant. So this constant equation will always be given in the form of phi xy is equal to constant. And we have a function fxy, okay, and that is equal to x square plus y square. But you know what? If this fxy, if this is minimum or maximum, this fxy is minimum or maximum, then we have that this df will obviously be 0. For the condition for maximum and minimum, the first differentiation, the total differentiation, that is the df will obviously be 0. And this is only for the case of minimum or maximum. And here we have to minimize the function. So obviously this df will be 0. And at the same time, as this constant equation phi xy is equal to constant, so we will have another equation also, that is df is equal to 0. So we have to use these two things. And you know, if you have a function that is f, which is a function of x and y, then we have the total differentiation df as the Puffian representation, you know, I think, that is del f by del x into dx plus del f by del y into dy. Similarly, we have d phi. So d phi will be what? That will be del phi by del x into dx plus del phi by del y into dy. So we have d phi and we have df, and these two are simultaneously 0. Because df is equal to 0 and d phi is equal to 0 also. So now what you can write? You can write this addition of these two with some constant is obviously 0. Because if df is equal to 0, then d phi is equal to 0. You always have to constant that will lead you alpha df plus beta d phi is equal to 0. And this alpha and beta are called Lagrange's multiplier. And you have to always choose this kind of constant. You know why? Because these two kinds of constant will always give you these two kinds of constants always give you the process, or always give you the method to add these two functions, this is df by d. But you cannot do like this. Okay, so please keep in mind, you cannot do that df plus d phi is equal to 0. This is not wrong, but this is not the general case. Because you know what? If df is equal to 0, then obviously some constant, if you multiply with this df some constant, then obviously this df is equal to 0, alpha df is equal to 0. And similarly, if we multiply with the d phi with some constant, then beta d phi is equal to 0. So there should be some proportionality constant. And you can think it in another way also. In physics, you can see that whenever you will get this kinds of situation, then this f and this phi will imply some physical quantity, and this alpha and beta will take care for this physical quantity to be same dimension, make same dimension. Because you cannot add two quantities which have different physical unit. Okay, suppose if this is energy, you will see in statistical mechanics, if this is energy and suppose this is the total number of particles. So energy and the total number of particles cannot be added. Energy and total number of particles cannot be added. So whenever these two quantity will carry some different physical dimension, then you cannot add these two quantity. But if you multiply with some constant, then there is a chance, there is a possibility to make it same dimension with this. So this alpha and beta are very significant, and these are not just constant, they are proportionality constant, you can say in mathematics, but in physics this alpha and beta are more significant because they will take care of unit also. Okay, so you have to multiply always. Whenever two things separately 0, you cannot add them without multiplying this thing, and this is known as the famous Lagrange multiplier. Lagrange is undetermined multiplier. So this alpha df plus beta d phi will give you finally 0. And what this alpha, and you can just instead of this two constant, you can make it one constant also. So if you divide this whole equation by alpha, then you will get df plus beta by alpha into d phi is equal to 0, and this beta by alpha you can take it as a lambda. So df plus lambda d phi is equal to 0. So we have to use this equation. Okay, so we have df and we have d phi. Now if you multiply this with lambda, then df plus lambda d phi is equal to 0, and this lambda is known as Lagrange multiplier. This lambda is known as Lagrange multiplier that we have to involve here. Okay, so what we will get finally? So let me see what we will get finally. So what we will get finally is, we have this df means what? This df means del f del x into dx plus del f del y into dy plus we have this lambda. So lambda and d phi is this. So we have del phi del x into dx plus del phi del y into dy is equal to 0. Obviously this will equal to 0. So now what it will give? It will give us two equations. One is, so please take x and y separately. So we have del f del x into dx plus we have lambda into del phi del x dx plus we have del f del y into dy, okay, plus lambda into del phi del y into dy is equal to 0. So it will give you separately, this thing will be 0 and this will also be 0. So you have equation del f del x into dx plus lambda into del phi del x into dx is equal to 0, equation 1, and we have another equation, that is del f del y into dy plus lambda into del phi del y into dy is equal to 0. So we have these two equations. So we have this equation and we have this equation. Okay, so from this equation we have to solve lambda. And obviously we have another equation, that is y is equal to 1 minus x square, and from there we will get x also. So if we solve from here lambda and y, then we will get x from here also. Okay, so we have to solve this first for lambda, then xy. So we need actually the point xy. So we can solve from here x and y. But now we are not going to use this result directly, because you can forget this result. But there is another way to remember this thing. You cannot actually remember this thing directly. Just you have to look this. Okay, so what this actually means, you can see here, this equation is actually nothing but, you can see from here that what this equation is. We can if you this is the complete differentiation, total differentiation. So if this whole function, if we take this as capital F, then obviously this capital F will be function of xy, and it can be written as in that case. So if this is df, obviously this is df. If f is a function of xy and this is nothing but the df, so you can choose f as xy. So this is function f x comma y and plus lambda, and this can be chosen as x comma y. So you can choose this function directly. For solving problem, you have to just form this, because you know f and you also know phi. Phi is what? This is phi actually. This is x square plus y is equal to 1. This is phi of xy. So you have phi of xy and you have f of xy. So you don't need to use this equation directly, because you can forget this. But you cannot forget this phi and f. And if you see that, we can construct a function capital F, which is nothing but the addition of these two functions f x comma y plus Lagrange multiplier into the constant equation, that is phi x comma y. So we have to always write this the problem in this form. That now if we differentiate this, you will get easily this and this also. So you will obviously get this thing from this equation, this capital F. So you don't need to use this algorithm that I have used for theory purpose. You have to just use this thing for problem solving purpose. You have to put this first. So let me solve the problem by using this method, this problem, the same problem, so that you can understand. Okay, so you have to just construct this function capital F, this function capital F. Okay, so how you can construct? You have f x comma y. So for this problem, what we have f is equal to this f, and this f is x square plus y square, and plus lambda into what we have? Phi is nothing but x square plus y. So we will have lambda into x square plus y. So just see, we have the theory that I have discussed, but we have to use this thing, this f directly. We don't need to use all the differentiation and all the equations that I have derived for this Lagrange multiplier process, the problem. But you have to just form this f for problem solving purpose. You don't need to do anything. You have to just form this f. Now what you have to do? You have to just take this and this. But how you can get? You have to just differentiation with respect to x and with respect to y. So if you get del f del x, then what you will get? You will get from here 2x, and you will get from here what? 2x lambda. And what will be del f del y? So del f del y will give you from here 2y plus this is just lambda. Okay, so this will also give you 0 separately, and this will also give you separately 0, because this is also 0, this is also 0. Okay, so you have this del f del x into dx and del phi del x into dx. All these things are involved here already automatically. So you can solve this problem in this way. So now this problem is very easy. Can you see that 2x plus 2x lambda is equal to 0. So you can find from here the points that if you can find, if you want to find. So this is very easy now. The problem is so easy now. Okay, so let me solve. So this is 2x plus 2x lambda is equal to 0. So it will give you 2x into 1 plus lambda is equal to 0. So this will give you x is equal to 0 and lambda is equal to minus 1. Now another thing, this 2y plus lambda is equal to 0. So you have also this 2y plus lambda is equal to 0. So what it will give? So you have to first find y. So what is y? How you can find y? Because we have one equation, y is equal to 1 minus x square. So if x is equal to 0, so if this x is equal to 0, then you will have y is equal to 1. And if you put here y is equal to 1, then what you will get? You will get 2 into 1 plus lambda is equal to 0. So you will get from here lambda is equal to 1. From here you will get this y is equal to 1 minus x square. So if you put this lambda is equal to minus 2, okay, at this equation, if you put here actually this 2y plus lambda is equal to 0, 2y plus lambda is equal to 0, that means 2y is equal to minus lambda. So if you put lambda is equal to minus 1, so it will give you 1. So y is equal to half. So when y is equal to half, you will get from here x square. So you will get this will be equal to half. So x square will be 1 minus half. So x square will be half. That you need actually. Okay. So this x square will be half. So obviously x will be plus minus 1 by root 2. So we have x is equal to 0 and x is equal to plus minus 1 by root 2, and you know, and I have discussed earlier that for minimum thing, for minimum point, you need actually this point, this x is equal to plus minus root 2. X is equal to 0 will give you the maximum. So again, we don't need to check the second derivative here, because from the problem we have get the hint that to minimize the function we have to know only that x is equal to plus minus 1 by root 2. But lambda is equal to minus 2 is not allowed here. Here lambda is equal to minus 1 is allowed. Okay, because for lambda is equal to minus 1 we will get this minimum value. Okay, so this is how we can solve the problem. Thank you.